We're now going to look at another reaction of enolates. This reaction is called the enolate alkylation. You recall that alkylation means to add a carbon group. There's actually two closely related enolate alkylations. The big difference between them is the conditions that are used to generate the enolate. If we look at both of them, they both start with a ketone. Aldehydes don't really work well for these reactions. They do side reactions. We're going to learn another reaction called the enamine, which does something very similar and works much better on aldehyde. So starting with a ketone, we treat it with strong base under either kinetic or thermodynamic conditions to get the regioisomer that we desire. And then we treat it with an alkyl halide. The enolate reacts with the alkyl halide via an SN2 reaction. The result then is a product where an alpha hydrogen has been replaced by the carbon group from the alkyl halide. LDA was discussed earlier, but here we can see what the actual structure is. LDA stands for lithium diisopropyl amide. It looks like this. It's a nitrogen with two isopropyl groups attached and a negative charge because it has been deprotonated. It's an extremely strong base and is also sterically hindered, which tends to favor formation of the kinetic product. The alkyl halide used in this reaction must be able to do an SN2 reaction. This means that it must not be sterically hindered. Generally, it's going to be limited to methyl and primary alkyl halides. The mechanism of this reaction is actually fairly simple. It starts with the ketone being deprotonated by the amide anion of LDA. It's a very strong base. It uses a lone pair, removes an alpha hydrogen, and we get an enolate. The enolate is resonance stabilized. I haven't drawn the resonance structures here. This is the important resonance structure for our reaction because it shows that the alpha carbon has a lone pair and a negative charge, which makes it a nucleophile. The nucleophilic alpha carbon then does an SN2 reaction, approaching from the backside of R' and knocking off the halide leaving group. This creates a new bond between the carbon group of the alkyl halide and the alpha carbon and results in our product.